All right, hello and welcome to Hexagon Mining's webinar on the topic of mine safety. My name is Benito, the field and channel marketer for Hexagon Mining in this region. And I will be facilitating this session along with today's speaker. This is the first in a series of free webinars being offered by Hexagon for this year. Today in particular is about the value of proximity detection technologies for preventing incidents and keeping people safe at all times in the mines. To show us the importance of safety and productivity and how Hexagon addresses the issue of collisions, we are joined by Mr. Nick Boswell, Business Development Manager for Asia Pacific of Hexagon Mining. And Nick will take over from Dean McAllister, who unfortunately couldn't join us today. I will now hand you over to Nick to begin today's session.
Thank you, Benito, and thank you everybody for attending today. Please remember to use the chat function if you'd like to talk with us. And today I will hopefully give you a better understanding of our proximity detection systems. My email address is just pointed out there on the slide, should you want to contact me or the team afterwards. So what are we going to talk about today? Well, first of all, why proximity detection? It is, of course, a means to an end, and we'll go into that. What is and why is our Mine Protect portfolio? And I'd like to introduce a structured framework of safety. We will then talk a little bit more about the hardware and the systems that go into our collision avoidance systems, which of course relies on proximity, a little bit about personal alerts, tracking radars, and finally moving into vehicle intervention and questions. So I won't waste any more time. Let's have a look. So why proximity detection? Well, essentially, good corporate governance and historically poor safety records have produced a growing pressure on our industries to reduce loss of life incidents. And it makes perfect economic sense to invest in safe operations. Over time, government bodies and inspectorates like the MSHA in the US and the Department of Mineral Resources in South Africa have prompted the creation of industry bodies. A major one is MCERT, as well as state-based independent inspectorates here in Australia. They want us to define and provide a positive pressure towards automation and control of heavy industrial equipment and earth-moving assets. On the slide there, we'll see the Earth-Moving Equipment Safety Roundtable, MCERT, of which Hexagon is a member. This is one such body that has a very high degree of mining industry participation and support. One of the things that MCERT has produced is a series of unwanted event scenarios. This is interactions between typically heavy vehicles as well as light vehicles or dozers. And I know that it's not terribly clear on this table, but essentially a local object, as it's known, now that might be my haul truck, is heading towards an event with another remote object. That might be your haul truck or light vehicle, a person or an obstacle or a void. Now, in that situation, Hexagon have developed technological solutions to provide the operator of that local and remote object with a proximity awareness of the other vehicle, followed by an advisory alert, and if necessary, we can actually force an intervention to reduce the chance of an unwanted event actually occurring. We do this with collision avoidance systems, tracking radars, fatigue or operator alertness systems, and personal alerts. This is a table generated to show different control levels and the time frames in which those control levels actually apply. The area of main concern to us in Hexagon is levels 7 and 8 controls and ultimately level 9. So there are 9 levels of control pertinent to our mining operations. We want to reduce the risk of defined unwanted events, as I saw in the previous slide. So namely, we are providing operators with a visual understanding of the proximity of threats, an audio alert of a pending collision, and if you have level 9 fitted on your vehicles, then an intervention to take control of the vehicle. So why Hexagon Protect? Look, incidents between vehicle to vehicles and mining equipment are great risks on any mine, mainly due to the volume of interactions and the variety of conditions available on mine sites. Now, we've just seen a really life-critical event shown on the screen. This is a haul truck against a light vehicle. Another really critical event is going to be interactions of shovels and excavators versus dozers. In other words, large equipment versus small equipment. The systems that we have can collect all the data associated with the equipment and vehicle interactions constantly, every few milliseconds. And by using a suitable analytics platform, such as the Hexagon's Mine Enterprise, it will be easy to focus your attention and actions on eliminating this rather small group of highly critical interactions. I'll call those HCIs. If you can concentrate all your information together, we can produce for you an evidence-based, clear return on investment that can be measured over a period of time. There's a justification in anyone's mind. So what is our ultimate goal? Our ultimate safety metric, if you like, is to eliminate fatalities through critical control systems and integration. We're going to just move to a standard risk management process, and that is where the Mine Enterprise will help you. It is the core of any good management system that is, you do need to have committed leadership. It's through leadership that you will get the alignment of your organization's objectives with the resources that are available. As you can see here, it is that control and mitigate, which is the main area. We identify, we assess and understand, control and mitigate, and then monitor and enforce, all with the leadership and safety culture of the organization. Mine Enterprise, the analytical-based software, can give you knowledge of situation-based events. It will give you a mapped out event density locations, overspeed events, and critical risks can be easily identified by querying the database. It will produce dashboards for you, and more critically, it will show you how you perform over time against those critical risks. And of course, we all know what the good goal is, the cup at the end of the day. So how do we get there? Step one, let's choose one of those highly critical events. You may choose, for example, light vehicle interactions with heavy vehicle interactions. You can write and optimize the reporting system to specifically look to that configuration. Work with that for a long period of time, perhaps 8 months. And then maybe you can choose your next highly critical interaction and work with that for a long period. Let's do that a little bit later on, after a further 5, 6, 7, 8 months. Now we can move to the medium controlled criticality events. But of course, don't take your eyes off the prize. You do need to make sure your really serious high critical events do not occur again or rise. Maintain that pressure. Further 8 months, you will minimize the number of incidents on site in a measurable way. So how do we do this? Let's have a look at the Mine Protect portfolio of products which we can offer you. This little graph here essentially shows the collision operating system here, which we will talk about in some depth, the safety cameras and visions around the haul trucks, safety alert tags, which individuals can wear, and of course our operator alertness systems or fatigue awareness that can be used. With tracking radars, you can then move forward to the vehicle intervention systems where decisions can be made if necessary. All of this integrates through the Mine Enterprise analytical software. So let's have a look at some of the hardware. This is split into three main areas. You may wish to start with the biggest bang for your, excuse me, the biggest bang for your buck, which is collision avoidance systems. On the left-hand side, you can see that the components are very few. There is a display rosette, there is a computer box, and some antennas. Very few components, very few connections, and this is the basis for your expansion into other areas. For example, if you wish to have personal alerts as well, 3 more antennas are placed on the vehicle, and the individual people have tags. We can then expand that to include radars and the vehicle intervention system, known as VIS. You can see the radars on the right-hand side joining into exactly the same system, and of course, an optional display. I will come to that in just a moment. Let's have a look at the display options. Option A, shall we call it, is our rosette display. This is a circular group of LEDs and some status LEDs in the display. These are typically good for light vehicles or for haulage trucks. It will show you the proximity of a vehicle to your vehicle with a green, amber, or red for a close, medium, or far distance. It will show you where it is in relation to you, i.e. behind, to the left, to the right, at an angle, or directly in front of you. There are combinations of alarms which will go off for non-proximity things. For example, tailgating, overspeed, an obstacle in front. We have another display which is more suitable for rotating equipment, as it gives you a plan view of your equipment in the center. On the right-hand side, for example, you can see you are centrally placed and you have a radar zone around you. In this particular example, there is one vehicle already located, and up in the top right, you can see that that vehicle is now very close to you, and it's now identified as a threat and has got colored red. Sorry, it's a little small, perhaps, on the slide. You will see on the left-hand side, as the vehicle moves out of the amber zone, it's into the green zone for the fact that it's out of the way of the bucket that you may have on your vehicle. And cameras can be integrated in as well. Let's have a look at some of the sensors that the collision avoidance system utilizes. Communication is multifold. On the left-hand side there, you can see V to V, which is vehicle to vehicle. So each vehicle knows the proximity of every other vehicle through radio frequency communication. This is out of line of sight, so you do not need to be within line of sight. We also employ an accelerometer in the equipment. That way, if you were doing an incident investigation, for example, you can see when the high vibration or the bumps occur. Harsh braking can also be recognized. Of course, we use GNSS or GPS through all of the different satellite constellations to give you maximum coverage. With the personal alerts, you may remember I said you would add another aerial or antenna and an alert tag. That's use a time of flight, ultra-wideband radio frequency signal. It is accurate to about 30 centimeters of location, so the clear, far, and near zones are easy to recognize. And of course, we have intelligent radar system. Let's see how these would communicate together. You can see here that each vehicle will be talking to each other, including the GPS, and all of that data goes back to the server, either through an LTE or cellular connection or site Wi-Fi. That's where all the data is updated and maintained, and the Mine Enterprise system can query that data for you easily. Perhaps one of the key elements to the success of Hexagon in this field is through its radar system and its dynamic safety zones. I'd like to show you a little bit more about that. Here we have a little video of a light vehicle approaching a heavy vehicle. See how the LED has gone green and now red? It's now red flashing as it passes, back to green, and then out of the proximity zone. That immediately shows how you have the proximity awareness within the system. Now, the actual dynamic safety zone is very important and gives us a particular advantage in this marketplace. Now, a normal GSS heading calculation ideally would be 0 error, but of course we all know that it's accurate perhaps to a couple of meters or so, which means that your vehicle could be heading in any different position along that ideal path of 8 meters wide. So you see here that we're going to have to move to a wider path to be able to predict the position of the vehicle as it stays within the 2 meter zone. There's the haul truck added to it. And if you use a static safety zone where the radar points directly in front of the vehicle and partly surrounding it, you will see that projection of those angles will make a very wide area of safety, maybe 14 meters wide. And that's in one direction. A haul road needs to be as narrow as is reasonably acceptable. So we employ the dynamic safety zone. You can see in the lower diagram there that we configure our zones to be tightly surrounding the vehicle, except in front, and we project that forwards. You'll also see a slight curve so that the radius of turn of the vehicle at any time is known, and that greatly reduces the possibility of nuisance alarms, particularly when you're passing by vehicles. This dynamic safety zone is so-called dynamic because a stationary vehicle will have its own area just around it, as you can see in the beginning of the graph on the right-hand side. And then as the vehicle speed increases, the dynamic zone increases in front of it. This allows a safe braking distance as the speed increases. You can see that a haul truck, for example, needs a lot more braking distance than that of a light vehicle. Up in the top right-hand side there, you will see that the interaction of the two zones when the vehicles get close, one causes an audible alarm and then a higher pitched, more rapid sound will indicate a high priority. Doesn't end there. Particularly in open mining, there is normally a pit to go down and haul roads can be quite steep. So for a constant speed, we actually measure the slope as well. And as that happens, you will see that the dynamic braking zone is increasing by 2%, 4, 6, 8%. And that's at constant speeds, depending on the inclination. Here's an example of the dynamic safety zone. See the haul truck moving here, nothing detected, and as it accelerates, the safety zone extends out in front, not to the side or behind. Another vehicle has just been detected at some point. It's getting close. There's an intersection, an alarm, the vehicle can stop. Now it's safe, the light vehicle can move on. Let's see how this happens on curves as well. And this shows one of the key differentiations between static and dynamic safety zones. So on the left-hand side, we have the dynamic safety zone, and on the right-hand side, without a fixed zone. So let's bring in a vehicle, and you can see on the dynamic safety zone, this area here, there is no interaction, even despite the fact that the haul truck is heading directly towards the other haul truck, but there is no intersection of the safety zone. Therefore, there is no alarm because there is no chance of a collision. If an alarm was caused, as on the right-hand side, that would be a nuisance alarm because you're not heading to the collision. consider the middle objective, an late alarm situation. Using the dynamic alarm, you can see that there is an early alarm caused as the light vehicle comes around the Hall Road bend. Even though with a static system on the right-hand side, they do not intersect because they're not on the same trajectory, and therefore you get a late alarm and a near miss, I hope. Tailgating is another feature for the dynamic alarm. Here's a tailgating situation. A vehicle is detected, one is accelerating, getting too close, audible alarm, you have the opportunity to back off. These distances are, of course, configurable to your mine situation. You may also have various speed limits that you want to enforce around the mine. Those speed limits can be done by geofencing, as we would call it. So various areas can be highlighted as 15 kilometers an hour or 20 or 40 kilometers an hour, depending on the vehicle type and the position. No-go areas, stockpiles can all be controlled as well. So let's just summarize some of the things we've seen here. It is a 360 degree, does not depend on line of sight. Vehicles are recognized up to about 500 meters or so away. So far, there are over 38,000 mining vehicles equipped with our collision avoidance systems. There are some 5,000 equipped with our anti-fatigue and operator alertness systems as well that measure the closure of the eyes to catch microsleeps. Over 10 years of experience have been developed into this product so far. So let's now move on a little bit to personal alerts. Personal alerts are tags worn by the operators, kept in positioning-wise with the time of flight area. And again, the same concept of danger close, close, okay, and out of range is done. Alarms will sound both on the tag and in the vehicle as well. Of course, there is a cab protection zone and an acknowledgement button so that you can be working on a vehicle going in and out of the cab as required without nuisance alarms. Perhaps at the pinnacle of the tree is a vehicle intervention system, or VIS, as we call it. VIS has the ability to take control of the vehicle in defined situations. It has a little decision engine on board, and as the last resort, it can apply the brakes or maybe disengage the throttles as well. So let's just have a look at its process. So you have the environment and you have the perception of your operator, and then the sensors with the prediction of what is going to be happening in the future. An assessment has to take place. 9 times out of 10, of course, that assessment is, this is not a problem, we are just giving you proximity notice. When you get too close, an alert may be required. And on a very quick basis, is a decision to intervene going to take place or not? And if the decision is yes, then it will implement a system to take control of the vehicle. So let's have a little look at the system in operation. The hardware of the system basically comprises of the CAS system. Here we have the CAS decision engine in the center, with, of course, the antenna, which we saw earlier, and the tracking radars and the LED display. How does that interface to the other equipment? Well, using the CAN bus interface, there would have to be a machine intervention controller. That controller is supplied normally by the OEM, and one of the points with Hexagon is we are not aligned with any of the OEM manufacturers. So whether it is a Caterpillar, haul truck, or maybe Komatsu, or Hitachi, Liebherr Machinery, Terex, all of which, if that machine interface controller would normally be provided by that OEM specifically, and would be connected to their control panel, and depending on the systems that you employ, to the gas, retarder, brakes, etc. There would of course be an acknowledgement button so that you can cancel out unwanted warnings in the event that they occur. It's almost a plug and play system. We would work very closely with your OEMs to show how the system works and to meet your needs. A quick word about the intelligent radars, as we mentioned earlier. Again, the radar system isn't a dumb radar. It covers near range, close range, and very close range. And you would have 3 of these typically installed, one on the rear for VIS, to allow for reversing situations. A normal radar will simply detect what's going on. And you see that on the left-hand side here. So the burn would be detected, and potentially alarm would go off in that situation. With our tracking radars, the burn is still detected, but it's in the safe zone. And indeed, in the middle drawing there, you'll see there's an object also in the way, but because it takes account of the turning radius of the vehicle, in this situation, you would not be getting a false alarm. In the last situation, on the right-hand side, there is an object in the way. It is picked up. It could be a moving object or stationary, and an alarm would sound for it. The application of vehicle intervention really fits into a few main scenarios. We have a launch assist, an asset protect, a speed assist, tailgating, ramp assist, and finally a brake assist. And this depends on the risk and complexity of your mine sites. For example, the brake assist is an imminent collision with a person or object, and your speed is below 10 kph, then we can implement brakes to do an emergency stop. Clearly, you wouldn't want to do an emergency stop at a high braking speed. Ramp assist, we've already mentioned this. If the gradient and you are getting is exceedingly too fast and you're beginning to go to an overspeed situation, and if you do not take corrective action, the brakes can be, again, or the retarder can be applied to reduce that overspeeding. Tailgating, again, that can be done automatically if required. Speed limits we've discussed. Asset protect is a good one. You may be in a delimited or a no-go area. Perhaps you are under the cables of power and you do want to disable the hoist or the tip on your bucket. And launch assist, of course, if you have a threat or a person or a problem in front or behind your vehicle, you can disable the startup. So I'm just about to run out of time. So just a few words about why I would love you to give me a call if you have an interest in the detail of this product. We've been doing this for a very long time. We have a wide range of solutions, all starting at the base module area, and you can build up as your needs change over time. I would suggest we are the market leader with over 38,000 CAS systems deployed, over 5,000 operator alert systems, and that's across all continents and 120 mines plus. We have vehicle intervention systems working particularly in South Africa, where the regulations are pushing towards that very quickly. Well, I'll say thank you very much, and we'll handle some questions.
Hi, it's Craig Power here. It seems to me that this system with some modification could be applied to underground mining. Have you approached underground mining?
I'll take that one. Yes, underground mining is applicable. The communication is probably a little harder. So Wi-Fi or leaky feeder communications would be the way to go. So updates to the system may have to occur in crib areas or on the surface, but it works very well indeed. It's just the reporting that's a little bit slow.
Oh, thanks for that. That's an excellent application. I've been involved in runaways in mines, and I've been involved in people being picked up by loader buckets in mines, and it seems that this would solve that problem.
Yes, yes, it does have application. Clearly, it's evolved in open pit mining mostly, but
Yes.
yes, I do have quite a few people who are talking to me about underground use of collision avoidance.
Okay, one more question.
Sure.
You mentioned your asset protect solution. Where now is that a 2D area or is that a 3D bubble around an area?
The layout is essentially 2D.
Okay.
So from a plan view, you may have an area. I mentioned the idea of power cables or perhaps a bridge.
Yes.
And you would delineate that as an area where you might have a weight limit or a height limit.
Yes.
And you'd want to in terms of vehicle intervention, you may want to disable the bucket tip function underneath power cables.
Yep. Understand. All right. Thank you.
No worries.
We did have a question that was asked on the chat box. It has been answered by my colleague Shane. The question went, what radio communication technology do you use for vehicle-to-vehicle connectivity? Yeah,
that has been answered. So essentially, it's RFI, so radio frequency transmission, independent of the company's Wi-Fi or network. So vehicle-to-vehicle communication and proximity detection will happen in the absence of Wi-Fi or any other connectivity. Yeah. All right. You don't, even if you lose your GPS settings as well, the vehicle-to-vehicle will still function.
Okay. To wrap up this webinar, again, I'd like to thank everyone and hope you enjoyed this session and enjoy the rest of your day. Thank you very much.